Hello everyone. So today I'm going to start discussing chapter 4, which is all about coordinate geometry. And let's start with the gradient of a straight line. So at the end of this discussion, you'll be able to find the gradient of a straight line given the coordinates of 2 points on it, and find the gradient of a straight line given its equation. Also, determine the relationship of the gradient values of parallel and or perpendicular lines. So let's begin. Consider this straight line on the xy plane. We can determine or define gradient as the thickness of this straight line. We have the vertical change and the horizontal change, or the distance vertically and the distance horizontally. The variable used to denote the gradient of a line is the variable m, and that is the ratio between the vertical change and the horizontal change. Let's say we have 2 points, A as x sub 1, y sub 1, and B as x sub 2, y sub 2. To determine the horizontal distance or the horizontal change, we have the difference between x sub 2 and x sub 1. To determine the vertical distance or the vertical change, that is y sub 2 minus y sub 1. Replacing this to m equals vertical change over horizontal change, we have m, which is the gradient, is equivalent to the ratio of y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And this is the formula for computing the gradient of a straight line given 2 points x sub 1, y sub 1, and x sub 2, y sub 2. Let's have the first example. Find the gradient of the line passing through each of the following pairs of points. Again, the formula for gradient is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. For letter A, we have 2 points C, 3, 1, and D, 6, 3. First, label each point as x sub 1, y sub 1, and x sub 2, y sub 2. Then using our formula for computing the gradient of the line, substitute y sub 2, 3 to y sub 2, 1 to y sub 1, 6 to x sub 2, and 3 to x sub 1. So that would be 3 minus 1 all over 6 minus 3. And the value is 2 over 3. The value of the gradient is positive. Remember, if the gradient of a straight line is a positive value, it means that the straight line is slanted upward to the right. Again, the straight line is slanted upward to the right. Letter B, H 5 negative 7 and K 0 negative 2. So find the gradient of the line passing through these 2 points. Again, label x sub 1, y sub 1 for point H and x sub 2, y sub 2 for point K. Substitute these values to our formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And that will be negative 2 minus negative 7 all over 0 minus 5. Simplify further, the answer is negative 1. Since the value of the gradient is a negative value, it means that the straight line is slanted downward to the right. The straight line is slanted downward to the right. Letter C, M, negative 4, 1, and N, 16, 1. Again, let the point M be x sub 1, y sub 1, and let the point N be x sub 2, y sub 2. The formula for the gradient M is equivalent to y2 minus y sub 1 all over x sub 2 minus x sub 1. Then substitute the values. That would be 1 minus 1 all over 16 minus negative 4. And that is 0 over 20. 0 over 20 is simplified as 0. So, if the gradient value is 0, it means that this straight line is a horizontal line or a line parallel to x-axis. Again, if the gradient value is 0, it means that the straight line is a horizontal line or a line parallel to x-axis. Letter D, P for -1 and Q for 5. So let's label P as x sub 1, y sub 1, and point Q as x sub 2, y sub 2. For the gradient M formula, we have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substitute the values, and that would be 5 minus -1 all over 4 minus 4, which is 6 over 0. Division by 0 is undefined. So we cannot define the exact value of the gradient. So if the answer is undefined, it means that this straight line is a vertical line or a line parallel to y-axis. Again, if the answer is undefined, it means that the straight line is a vertical line or a line parallel to y-axis. So if the gradient value is positive, that is slanted upward to the right. If the gradient value is negative, that is slanting downward to the right. If the gradient value is 0, that is a horizontal line or a line parallel to x-axis. And if the gradient is undefined, it means it is a vertical line or a line parallel to y-axis. Let's have a practice. So find the gradient of the line passing through each of the following pairs of points. A, 0, 0, B, -2, 1. Pause this video and try to solve the gradient value on your journal. Let's answer this one. Let A be our x sub 1, y sub 1, and B as our x sub 2, y sub 2. Substitute to the gradient M formula, which is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substitute the values. That would be 1 minus 0 all over -2 minus 0. And that is -1/2. So the gradient value is -1/2. Since this is negative, it is slanting downward to the right. Letter C, E, -2, 4, and F, -5, 8. Pause this video and try to solve the gradient value of the line passing through these 2 points. All right, let E be the point x sub 1, y sub 1, and let F be the point x sub 2, y sub 2. So our gradient M formula is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substitute the values, and that would be 8 minus 4 all over -5 minus -2. And that is -4 over 3. Again, it's a negative value, meaning the straight line is slanted downward to the right. Letter E, I, -2, -5, and J, 2, 6. Practice solving the gradient value of the line that passes through these 2 points in your journal. Pause this video. All right. The point I is x sub 1, y sub 1, and point j is x sub 2, y sub 2. Our gradient M formula is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substitute the values, and that would be 6 minus negative 5 all over 2 minus negative 2. And the answer is 11 over 4. The value of the gradient is positive, meaning the straight line is slanted upward to the right. All right, I hope everything is clear in computing the gradient values given 2 points on the line. Now let's have practice number 2. The points A, B, C, and D and E are shown in the diagram. Find the gradient of the line AB, the line AE, the line DC, and the line D. Pause this video and compute the gradient values in your journal. All right, these are the gradient values of AB, that is 0, AE, that's 1 half, DC, that's negative 5 over 6, and DE, that's negative 1 over 6. Check your own work. All right, so let's move to the next example. If the gradient of the line joining the points for negative 9 and negative 3h is negative 4, find the value of h. From this problem, we can let 4 negative 9 as x sub 1, y sub 1, and negative 3h as our x sub 2, y sub 2, where negative 4 is the value of m. Since this is the formula, we can substitute negative 4 to m, and then substitute the values for negative 9, negative 3, and h for x sub 1, y sub 1, and x sub 2, y sub 2, respectively. And that would be negative 4 equals h minus negative 9 all over negative 3 minus 4. Simplifying this, it will become negative 4 equals h plus 9 over negative 7. Cross multiply, that is negative 4 times negative 7 is 28 equals h plus 9. And moving 9 to the left side, combining with 28, the value of h is 19. Example number 3. The collinear points P, Q, and R have coordinates 6, negative 11, K, negative 9, 2K, negative 3, respectively. Find the value of K. When you say collinear, it means that the points P, Q, and R lie on the same line, which means the gradient of 6, negative 11, and K, negative 9 is the same value as the gradient of K, negative 9 to K, negative 3 because they are collinear. So to compute the gradient of 6, negative 11, K, negative 9, assign x sub 1, y sub 1 to 6, negative 11, and x sub 2, y sub 2 to k, negative 9, and substitute to the formula. Same thing for k, negative 9 to k, negative 3 as x sub 1, y sub 1, x sub 2, y sub 2, respectively, and substitute to the formula and equate the two. So we have negative 9 minus negative 11 all over k minus 6 equals negative 3 minus negative 9 all over 2k minus k. Simplifying, it would be 2 over k minus 6 equals 6 over k. Cross multiply, so 2k equals 6 times k minus 6, where the right side will become 6k minus 36. Moving 2k to the right side, combining with 6k, it will become 4k, and negative 36 would be moved to the left side. And that is 36 equals 4k. Divide both sides by 4, hence k is 9. Let's have the practice. Get your journal and try to solve this problem. If the gradient of the line joining the points negative 3, negative 7, and 4, p is 3 over 5, find the value of p. Pause this video and solve the value of p. All right, so let's say negative 3, negative 7 is our x sub 1, y sub 1. 4p is our x sub 2, y sub 2, and 3/5 is the value of m. Since our formula is m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, substitute the values. That will be 3 over 5 equals p minus negative 7 all over 4 minus negative 3. Simplifying the equation, that will become 3 over 5 equals p plus 7 over 7. Cross multiply. 3 times 7 is 21 equals 5 times p plus 7, and 5 times p plus 7 is 5p plus 35. Combining like terms, p is negative 14 over 5. Alright, so let's move to practice number 4. The gradient of the line joining the points 9a and 2a1 is 2 over a, where a is not equal to 0. Find the possible values of a. Solve this in your journal. Pause this video. Alright, let's let 9a as x sub 1, y sub 1, and then 2a minus 2a1 is our x sub 2, y sub 2, and 2 over a is our m. Substitute to our formula, that will become 2 over a equals 1 minus a all over 2a minus 9. Cross multiply, so 2 times 2a minus 9 equals a times 1 minus a. And that will be 4a minus 18 equals a minus a squared. Since this is a quadratic equation, let's rearrange this wherein all the terms are on one side of the equation. So that will become positive a squared plus 3a minus 18 equals 0. Solve the value of a by using factorizing or using quadratic formula. This can be factored into a plus 6 times a minus 3. So the values of a is negative 6 or positive 3. And for the last example, we have the points p to negative 3, q 3, -2, and R, 8Z are collinear. So again, when you say collinear, these 3 points lie on the same line. Find the value of Z. Pause this video and solve the value of Z in your journal. Alright, since they are collinear, we can say that the gradient of points PQ is the same thing as the gradient of points QR. So assign P as x sub 1, y sub 1, Q as y sub 1, x sub 2, y sub 2 rather, and substitute to the formula. Assign x sub 1, y sub 1 to Q, and x sub 2, y sub 2 to R, and substitute to the same formula, and then equate. So we have -2 minus -3 all over 3 minus 2 for the gradient of the line passing through the points PQ, while z minus -2 all over 8 minus 3 is the gradient of the line passing through the points QR. Simplifying, it will become 1 over 1 equals z plus 2 over 5. Cross multiply, that will become 5 equals z plus 2. Therefore, the value of z is positive 3. I hope everything is clear when it comes to computing the gradient of a straight line given 2 points with the formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So to summarize that, gradient of a line means the steepness of a line. And to compute the gradient given 2 points, we have the formula y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Thank you for listening.